Hi! In every competition, we need to pre-process given dataset and generate new features from existing ones. This is often required to stay on the same track with other competitors, and sometimes careful feature pre-processing and feature engineering can give you the edge you are striving to achieve. Thus, in the next videos, we will cover a very useful topic of basic feature pre-processing and basic feature generation for different types of features. Namely, we will go through numeric features, categorical features, datetime features, and coordinate features. And in the last video, we will discuss missing values. Besides that, we often will discuss dependence of pre-processing and generation on the model we are going to use. So, the broad goal of the next videos is to help you acquire these highly required skills. To get an idea of following topics, let's start with an example of data similar to what we may encounter in competition, and take a look at a well-known Titanic dataset. It stores data about people who were on the Titanic liner during its last trip. Here we have a typical data frame we work with in competitions. Each row represents a person, and each column is a feature. We have different kinds of features here. For example, the values in survived column are either 0 or 1, the feature is binary, and by the way, it is what we need to predict in this task, it is our target. So, age and fare are numeric features, CBSP and parch are counts, sex, cabin and embarked are categorical features, ticket is just an ID, and name is text. So, indeed, we have different feature types here, but do we understand why we should care about different features having different types? Well, there are two main reasons for it, namely, strong connection between pre-processing and our model, and common feature generation methods for each feature type. First, let's discuss feature pre-processing. Most of times, we can just take raw features, fit our favorite model, and expect it to get great results. Each type of feature has its own ways to be pre-processed in order to improve quality of a model. In other words, choice of pre-processing method depends on the model we are going to use. For example, let's suppose that target has non-linear dependency on p-class feature. P-class value of 1 usually leads to target of 1, 2 leads to 0, and 3 leads to 1 again. Clearly, because this is not a linear dependency, linear model won't get a good result here. So, in order to improve a linear model's quality, we may want to pre-process p-class feature in some way, for example with a so-called one-hot encoder, which will replace our feature with 3, one for each of p-class values. The linear model will fit much better now than in the previous case. However, random forest does not require this feature to be transformed at all. Random forest can easily put each p-class in separate leaf and predict fine probabilities. So, that was an example of pre-processing. The second reason why we should be aware of different feature types is to ease generation of new features. Feature types differ in this, and comprehending common feature generation methods will gain you an ability to improve your model through them. Also, understanding of basics of feature generation will aid you greatly in upcoming advanced feature topics from our course. As in the first point, understanding of a model here can help us to create useful features. Let me show you an example. Say, we are to predict a number of apples a shop will sell each day next week, and we already have a couple of months sales history as a training data. Let's consider that we have an obvious linear trend throughout the data, and we want to inform the model about it. To provide you a visual example, we put here the second table with last days from train and first days from test. One way to help model utilize linear trend is to add feature indicating the week number passed. With this feature, linear model can successfully find an existing linear dependency. On the other hand, a gradient boosting decision tree will use this feature to calculate something like mean target value for each week. Here, I calculated mean values manually and printed them in the data frame. We are going to predict number of apples for the 6th week. Note that we indeed have linear trend here. So let's plot how gradient boosting decision tree will split the week feature. As we do not train gradient boosting decision tree on the 6th week, it will not put splits between the 5th and the 6th weeks. Then, when we will predict number of apples for the 6th week, the model will end up using the value from the 5th week. As we can see, unfortunately, no usage of linear trend here. And vice versa, we can come up with an example of generated feature that will be beneficial for gradient boosting decision tree and useless for linear model. So this example shows us that our approach to feature generation should rely on understanding of employed model. To summarize this video, first, feature pre-processing is a necessary instrument you have to use to adapt data to your model. Second, feature generation is a very powerful technique which can aid you significantly in competitions and sometimes provide you the required edge. And at last, both feature pre-processing and feature generation depend on model you are going to use. So these three topics in connection to feature types will be general theme of the next videos. We will thoroughly examine most frequent methods which you can be able to incorporate in your solutions. Good luck!